Hello everyone, welcome to this video. Today I'm going to talk about this article. This article tells us everything about MLOps, so I hope you enjoy it. In this article, the authors discuss the MLOps process, the types of tasks an MLOps engineer performs, the types of tools they use, and more. So let's go ahead and dive into it. So where does MLOps come from? Or rather, what does MLOps come to solve? MLOps stand for Machine Learning Operations. And with the rapid progress in machine learning and artificial intelligence, along with the explosion of data, there's a growing demand for ML-driven solutions to tackle real-world business challenges. For instance, retailers use AI to predict customer behavior, while logistics companies rely on ML models to optimize delivery routes. More and more companies are transforming their operation by building environments that can support this kind of intelligent systems. To make this transformation possible and sustainable, they need to adopt machine learning operations, that is MLOps, which helps streamline the deployment, monitoring and maintenance of ML models in production. What is the MLOps process? The first stage is the experimentation stage, where the data is collected, prepared for training the model, along with the model selection. Then comes the development stage, in which the model is trained and tested. And the last is the operation stage, where the model is hosted on servers as a service and is continually retrained over new coming data and revalidated at the same time. To define MLOps, it can be said that MLOps is now the standard way to deploy machine learning algorithms and managing their life cycle. And the advantage that we have with MLOps is deploying ML algorithm to server and scaling projects for real-world use. Due to the constant evolution of machine learning algorithm, the technology often lacks full maturity. As a result, only traditional ML methods can be reliably applied, and close collaboration between teams becomes essential. Pipelines must be well coordinated to avoid error caused by incompatible processing steps or dependencies. Version updates to ML service is not like code updates to basic software programs, as code updates can be made by just creating changes and testing them instantly. But for ML products, continuous retraining and reevaluation is a crucial step which consumes both time and resources. Continuous monitoring is essential, as data can change over time, requiring the model to adapt to new trends and evolving needs. What is the goal of MLOps? The goal is to create an environment where all teams are connected and work in harmony, enabling better products while increasing speed and productivity through automation. To create this environment, we have different phases: collecting the data, preprocessing, and feature extraction. Best model for the task is selected. Data from the data store is used to train the model. Hyperparameter tuning and evaluation is done. Version logging and models. The model is deployed to the server using specialized tools, monitoring of the model metrics to keep it up to date and increase the performance to perform this task. 3 pipelines are used: the continuous integration pipeline, the continuous delivery pipeline, and the continuous training pipeline. The first challenge we have in MLOps is the compatibility between pipelines. MLOps uses various types of automated pipelines. For example, the features are extracted in one pipeline, the trained model is hosted using some other pipelines. It is important that all these pipelines are compatible with each other, and the choice of tools for automation is correct. If the pipelines are not compatible with each other, or the preprocessing libraries do not match, it could cause many sorts of errors. The second challenge is the data. It's the most important part for MLOps, but it becomes a big challenge when there is a lot of data coming up all the time. It's important to ensure that the data we use to retrain our models is relevant and looks like how we expect it to be. Monitoring helps us see if the model needs to be retrained on new data to increase the performance, or if there is a data shift that would require us to completely change the model. Finally, we have the problem of overfitting. Overfitting is a real issue in the ML models. Evaluating models and keep checking for overfitting can save a company from a lot of challenges associated with the performance. Changes of having biased models should be eliminated completely. A biased model can cause bad reputation for the business and can even lead to legal proceedings. Legal and ethical considerations are also important for MLOps. It is to be made sure that the models are for the betterment of the people and cannot be biased towards a single group in any way. It is to make sure that the model does not save personal information like names, telephone numbers, addresses, bank account details, etc. The privacy of the users should be taken seriously. Another thing to be considered is the use of proper licensing for all the tools and modules used to provide protection to the intellectual property of the creators of these tools and modules. Legal actions can also be taken on the service if the service provides false or tempered outputs which deviate from the real results. The tools and platforms which are used to make these efficient pipelines that are automated to do all the tasks in the ML model's life cycle, from data exploration to hosting the model as a prediction service and introducing CI, CD, and CT capabilities to these pipelines. There are a huge number of tools now available in market for each task in the pipeline, and those tools work in comparison with each other to give the reasonable prediction results, speed, and performance. In the data preprocessing phase, we have two types of tools. One of the types is called labeling tools, and the other is called versioning tools. The labeling tools are used to label the data. This could be for the annotation of image data, changing file names, specifying file types, etc. The versioning tools are used to create multiple versions of the data and stored in a well-organized way. The performance of the model is dependent on the tool that is used, as it is somewhat based on the labeling accuracy of the tool. The image shows some of these tools. Modeling tools are used for three purposes and hence have three types. The first type is feature extraction tools, which are used to do fast feature engineering on the dataset to find out the best features in the dataset. The other type is the experiment tracking tool, which help keep track of various versions of the task created with different models and hyperparameters. And the third is used for hyperparameter tuning and are called hyperparameter optimization tools. The image shows some of these tools. The machine learning models, when put to real world, they face degradation after some period of time, as the data never remains the same, and due to this, data drift changes have to be made to the prediction service. For this reason, the model has to be monitored at all times. This task is usually done using tools that raise an alert in case there is a data drift or any anomalies in the pipeline. The tools that are used to integrate the ML models into production are called deployment tools. The image shows some of these tools. As every task is different from the other, there is no set rule to define which tool is the best. The selection of tools is dependent on the application. The good approach is to use the least number of tools possible to give the desired performance, as adding more tools can cause compatibility issues. But in case we need to have more flexibility, we can use more tools. In the paper, the authors mentioned some frameworks available to do this task. These frameworks provide the users with special tools that help them through the whole ML service lifecycle. These frameworks are intended to handle machine learning's particular issues, such as data preprocessing, model construction, and model deployment. Some of these are TensorFlow, Extended, Kubeflow, and StackMaker, but there are others. To finish, the users propose the design of a whole ML system. To do this, they apply all the MLOps concepts discussed above. The first thing to do is understand the business. In this case, they're trying to detect animals in images. So here we have an object detection problem. Next, we need to collect and validate the data to ensure all images are valid and usable. This task is performed by data science. Next, the preprocessing and data labeling tasks are necessary. Preprocess the data, split into partitions for testing and training, data augmentation, labeling, touching the data, etc. This task is performed by data analysts. Next, we have to choose the right model, at least for the first experiments. The chosen model is SSD ResNet 101. Evaluation and hyperparameter tuning are important too. Then we need to create a web app to provide an interface. Flask, HTML, and CSS are used. Package the model with Docker. The goal of doing that process, packaging the model into a Docker container, is to ensure that the web application that uses the machine learning model runs reliable and consistently in any environment. The container that we create now needs to be deployed to the server for making predictions. We can use Heroku with GitHub Actions, automatic CI and CD pipelines, or Kubernetes, which replaces Heroku. Versioning can be a small update in the code or a completely new model to overcome the data drift. To finish, we have to test on our prediction service to make sure it performs as expected in the real world environment. So that's all for this video, and thank you for watching. I hope you enjoy it. Bye bye.